Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Math 11 content. What we're going to cover today is going to be the present value of an annuity. So with that, let's get started. All right, so here we are. So what I'm going to do is write the formula first, okay, for the present value annuity, okay? And it's going to be R. And I'm going to use the square bracket here. So 1 minus 1 plus I to the power of negative n. Okay, and the whole thing is going to be over I. Okay, so the present value annuity basically means how much money do you need to invest right now. Okay, and in the future, I want to withdraw a certain sum of money, maybe every month or so, which is common. So this is really important, maybe like when you retire and you want to make some monthly withdrawals because you're not going to be working anymore. Okay, so let's try this example here. Okay, one more time, the PV represents the present value, okay, and the R represents the monthly withdrawals, and the I is the interest rate, okay, make sure you're watching again the compounding period, and N is the number of years, okay, and it will change with the compounding period. I is the interest rate, okay, and it should be in percentage, and you're changing it into a decimal when you put it in the formula. All right, so I'm going to read this question out loud. Josh is putting away summer earnings into an annuity from which he can withdraw living expenses while he's at university. So that's a good example as well. You're saving some money for university or college. He will need to withdraw $900 per month for 8 months. Okay, so I'm going to put PV equals 900. For 8 months, the interest earned is 6% and it's compounded monthly. Okay. So we're doing 1 minus, okay? And again, when you're compounding it monthly, let's write it on the side here, okay? So what we're doing is finding the value of I is 6%, okay? I'm going to do 6 divided by 100, so 0.06, okay? And when it is compounded monthly, I'm going to do 0.06 divided by 12. Okay, and if you put that in your calculator, we're getting 0.005. Okay, we have to make sure we do that. We were doing it also with the compound interest formula as well. Okay, so what we're putting in our formula, 1 plus 0.005. Remember the value of n here is negative. Okay, n is a compounding period here. Okay, and this is going to be for 8 months here, and it's compounded monthly. So we're just going to use n as 8. Okay, power of negative 8. And the whole thing is going to be over I, so 0.005. Does everyone see that? Again, make sure when you're putting this in your calculator, it's really important that I'm using the double brackets here. Okay, if I'm doing this separately, I have to actually do the brackets here, the small brackets first. Whatever answer you get, I have to do 1 minus my answer. Does everyone see that? And then times it by 900. Keep pressing the equal sign in between. And then you're going to divide it by 0.005. Okay, we are getting an approximate value here, $7,040.66. Does everyone see that? Okay, so Josh needs to invest $7,040.66 at the beginning of the school year to finance the annuity, okay? And the reason he's able to take out or withdraw a larger sum of money here is because he is still getting interest, okay? So let's try another example. Okay, this time we're actually going to try solving for the value of R, okay? So what I like to do is just write out the formula, plug in all of the values that are given, and then you can rearrange to solve for R. Okay, so let me read out the question here. So Fiona's life savings total $300,000 when she decides to retire. She plans an annuity that will pay her quarterly for the next 30 years. Okay, so let's write the formula out. Okay, it is important. If you want to just write out what's given in the question on the side, that's a good idea as well. Okay, so equals. So again, so she has $300,000 for her retirement. If her account earns 5.2% annual interest and it's compounded quarterly, how much can she actually withdraw each quarter? Okay, so this is quarterly means 4 times a year. She's going to be withdrawing the money. And we're actually solving for the value of R here. Okay, so we'll put 1 minus, and let's solve for the value of I on the side here. Okay, this is 5.2%. So we're going to divide it by 100. So 0.052. Does everyone see that? Okay, then I'm going to take this value and I'm going to divide it by 4. Okay, because this is compounded quarterly. And we're getting 0.013. Okay, the value of N, okay, which is the compounding period. So she wants to withdraw this money for the next 30 years because it's compounded quarterly. We're going to times it by 4. So the value of N is 120. So I always like writing the value of I and N on the side before I actually plug it into the formula. Okay, so let's put this in here. Okay, and we're going to plug in our value of I. Okay, and as well as the value of N. So 0.013 to the negative 120 over the value of I, so 0.013. Okay, so just like this. Okay, it looks a little bit complicated, but it's really not. What we're going to do is just move the 0.013 to the other side. So let's just times it here. Okay, and put that in your calculator here. Okay, and we're getting 3,900. Okay, equals R. Okay, and what we're going to do here is plug in this whole value, okay? But in brackets, I'm just going to write down what you're doing here. Okay, so what we're doing is 1 minus the 1.013 to the power of negative 120. Okay, so just like this. When you're solving for the value of R, okay, you notice that you have to actually divide by this whole number. So I'm going to write it here. R equals 3,900 divided by, and put this in your calculator here. I'm just going to put in brackets. Okay, and again, make sure when you do that, I'm doing 1.013 to the power of negative 120 first. And then I'm doing 1 minus whatever the value is that I'm getting here. Everyone see that? Okay, so let's put it in our calculator. Okay, and so make sure you're not dividing it the other way around. Okay, and we are getting approximately $4,950.87. Okay, so this is how much she's able to withdraw quarterly, which is 4 times a month, and that's actually not bad if you really think about it. Okay, and again, remember when you're putting money into the RSP, it will be taxed when you're taking it out. So that's something you should take into account as well. Okay, everyone's good? So with that, let's try one last question. Okay, just utilizing this formula. Okay, so one more time, I'm just going to read the question out loud. Let's put example. Okay, so Lauren plans to withdraw $650. I'm going to just write the equation. Okay, and you realize once you use the equation a few times, you'll get really good at it. Okay, over I. Okay, so Lauren is withdrawing $650, which is the value of R. At the end of every 3 months for 5 years from an account, it earns 6.4% interest. Okay, and it is compounded quarterly. Okay, so what we're going to do, okay, is let's do the value of I here. Let's do it on the side. Okay, so I is 8%. Oh, sorry. So I is 6.4%. Okay, I'm going to divide it by 100. So 0.064. Okay, this is compounded quarterly again, just like the last question. Okay, so I'm going to take 0.064 divided by 4. So 0.016. Okay, this is the value of I. Okay, and then the value of N is basically she's doing it for 5 years compounded quarterly, so times 4, which is 20. Okay, so we're going to plug this into our equation here. So 1 minus 1 plus 0.016 to the power of negative 20. And the whole thing is over I. Does everyone see that? So just like this. Okay, so this was 6.4, okay, as our percent. I'm going to put this into my calculator. The question is, determine the present value of the annuity, okay? And then when we put this into our calculator, we're getting approximately $11,050.41. Everyone see that? And this is the value. This is my present value. This is how much she actually has to invest right now if she wants to take out $650 from this account every month. Okay? Again, it's a good idea. The 6.4% interest is pretty high. And that way she's actually making some money as well. Okay? All right. So that looks good. And if there are no questions, that does bring this video to an end. I hope everyone did understand how to calculate the present value of an annuity using the formula. Make sure you do keep on practicing. And thank you so much for watching this video. And I will see everyone next time. Bye.